All right, today we're going to be looking at section 4.5 and its rational functions. We got two objectives. The first is for a rational function, we're going to find the domain and graph the function identifying all of its asymptotes. And the second just says solve applied problems involving rational functions. Okay, so I'm going to just go over the section highlights. It is good to kind of read. They show you several examples that you can kind of look at and see what these rational functions look like. They give you the definition of a rational function. It just tells you that f, which is representing our function, is the quotient. So you're dividing two polynomials, so two different equations. You kind of see different examples up here. So 1 over x, 1 is a polynomial, x is, same for all the rest. Here's an example where they say find the domain. Basically, you find what makes the denominator 0 and you remove that. And they're going over that here. But I will go over that in more detail when we start working and solving problems. But they give you several and they kind of show you what the domain looks like. And then we get into the asymptote. So this is one of the first objectives, finding the asymptotes. So vertical asymptote is one of the first ones. Here is how you determine the vertical asymptote. You have a rational function, so a polynomial divided by another one. It tells you that the bottom is not 0. If they have no common factors, so we'll try to break it down, find any common factors. And then we'll look at any other constraints maybe on the polynomial. So if a is a 0 for the denominator, so anything that makes the denominator 0, we will denote as x equals whatever that value is. In this case, we're using a. That will be a vertical asymptote. So that's just a general definition. Again, I will show you how to do that when we start working it out. They give you a few examples, but I'm going to skip over because I'm going to, again, just focus on the highlights. We start talking about a horizontal asymptote. Okay, horizontal is going to be a line y equals b, or y equals some number. And they're showing you that here, some visuals. And let's jump over to that definition right here. Here's how we determine a horizontal asymptote. So there are three key points that we need to look at. So when you want to determine if there's a horizontal asymptote, three things. We look at the numerator and the denominator. They both have a rational degree. If the degree is the same, okay, which I'll show you some examples here shortly. If the degree is the same, the horizontal asymptote will be y equals the coefficient of the numerator divided by the coefficient of the denominator. And they say that here, a over b, where a and b are leading coefficients of numerator and denominator. When the degree of the numerator is less than the degree of the denominator, the horizontal asymptote will be y equals 0. And then when the degree of the numerator is greater than the degree of the denominator, there will be no horizontal asymptote. So you got three scenarios. They are the same. The bottom is greater, and then you have the top being greater. And then there's one more. We have oblique asymptote or slant. They both mean the same thing. So if you see oblique or slant, this is how you determine an oblique or slant. So it tells you the occurrence of asymptotes. Down here, oblique asymptote occurs when the degree of the numerator is 1 greater than the denominator. So this kind of gives you an overview of everything together. Vertical, whatever makes the denominator 0. The horizontal, when the degree of the numerator is less, you have 0. And then horizontal, when the numerator and denominator are the same. And then oblique. So this is just kind of a general overview of everything together. And then they kind of give you some summaries as well. And then they start solving a few more problems. So let me just write down a physical note that we can use. So I'm going to abbreviate this. So I'm going to say VA for vertical asymptote. X equals some number, okay? and that is, for an example, let's say we had 1 over x minus 2. In order to figure out what this number is, we take the bottom and find out what makes it 0. So we will say, and that also tells you the domain. Okay, domain helps you with the vertical asymptote. We're going to say x minus 2 equals 0. If we add 2 to both sides, we get x equals 2. Or for domain, it cannot be equal to 0. I should say not equal. So domain, x cannot equal 0, which means x cannot equal 2, and that x equals 2 is also going to be where we're going to have the vertical asymptote. All right, the horizontal asymptote, HA, I'm going to abbreviate, it's going to be y equals some number. Okay, that number is going to be determined by one of 3 scenarios. So 1 is, for an example, let's say we had a 3x squared plus dot dot dot. We don't know what the rest is. Let's say on the bottom we have a 4x squared dot dot dot. Okay, so the degree 2 of the top is the same as degree 2 of the bottom. So when they have the same, the horizontal asymptote will be the ratio of those two. So it would be 3 over 4. So this is case 1. All right, case 2. If the degree of the bottom is greater than the top, so let's just say we had x minus 3, and let's say we had x squared plus 5x minus 7, maybe it doesn't factor. The degree of the top is understood to be a 1. Okay, we don't really write that. The degree of the bottom is 2. When the degree of the bottom is greater, your horizontal asymptote is y equals 0. And then case number 3, slide up a little bit. The degree of the top is greater, so let's just say we had an x to the third plus x minus 3, doesn't matter. And over here, let's just say we got x plus 5. Okay, so the degree of the top is bigger than the bottom, 3 over 0. There is no horizontal asymptote, so no HA. Okay. And then there's one other. We have an oblique asymptote. Okay, so I'm just going to abbreviate it OA for oblique asymptote. And that's going to be y equals some linear factor. Let's just say bx plus c. So usually a linear equation. The way you get that linear equation, you would have to do long division. So let's say we have y equals x squared plus 2x minus 1, and I'll go ahead and do it over x minus 3. Just say, for example, this is our equation. We would have to do long division to find out this asymptote. So the top goes in the long division bar. So we have x squared plus 2x minus 1, and then the x minus 3 is what we are dividing by. And we are only looking at the quotient part, we're not looking at the remainder. So I want these two to be the same, so I would need one additional x to make x squared, so we just need an x here. So I want to multiply both of these by x. So x times x will give me x squared, x times 3 will give me a minus 3x. And then we have to change the signs when we do long division. So this will become negative, this will become positive. And then that will go to 0. This will come down to 5x. And then we bring down the next term, so minus 1. And again, I just focus on this. I want my x to be 5x, so I need to multiply by 5. So I will say plus 5. Okay, at this point, we are done. This is my slant asymptote. Y equals x plus 5. Okay, you keep going. It doesn't matter. We'll get a 5x. 5 times 3, that'll give us a negative 15. You'll change the signs. That will become negative. This will become positive. That will zero out, and this will be a remainder of 14. Okay, that 14 does not matter. We are only concerned with the linear aspect. So this would be our slant asymptote. It'll always be a linear equation. So this will just be a rough overview, and I'll refer to this, these guidelines. So vertical asymptote, focus on the denominator. You would have to make sure there's no common factors in the numerator and denominator. Set the denominator equal to 0. That will give you your domain and your vertical asymptote. Horizontal asymptote, there are 3 scenarios that you look at. First one we're looking at, the degree is the same. Your y-asymptote is the ratio of those coefficients. Second scenario, the degree of the bottom is bigger than the top. That's always going to be 0. Third scenario, the top is greater than the bottom. You do not have a horizontal, but you could pick up an oblique. You will pick up an oblique if and only if the degree of the top is exactly 1 greater than the bottom. So it has to be 1 more than the bottom. All right, so with that, we're going to jump over to my math lab and start doing some examples.